In this video, we are going to define the methodology of analyzing a discrete time system in time domain, or we can say it like solution of difference equation. Let us start with an example. Let us take this problem. Find the natural response of a system described by the difference equation y of n minus 1.5 y of n minus 1 plus 0.5 y of n minus 2 is equal to x of n. The initial conditions are provided like y of minus 1 is equal to 1 and y of minus 2 equal to 0. So we will go for the solution of this equation. Let us consider the given equation as equation number 1. Since it is asked like natural response of the system, natural response basically is called the input response. So natural response can also be called as zero input response. So equation 1 can be written as y of n minus 1.5 y of n minus 1 plus 0.5 y of n minus 2 is equal to 0, because 0 input in the sense x of n is equal to 0. So we are supposed to find the solution for this homogeneous equation. We can write this as equation number 2, and we can find the solution for this homogeneous equation. And in general form, if you have a difference equation, the solution of this homogeneous equation will be looking like of the form yh of n will be equal to lambda power n. So taking that into account, the equation 2 can be written as lambda power n minus 1.5 lambda power n minus 1 plus 0.5 lambda power n minus 2 equal to 0. Let me take lambda power n minus 2 to be 0. Lambda power n minus 2 is common. Lambda power n minus 2 is common. So I will have a lambda squared minus 1.5 lambda plus 0.5 is equal to 0. So I will consider these equation to get we call this equation as a characteristic equation, and we will try to find the eigenvalues or roots of this equation. I will get lambda minus 1 and lambda minus 0.5 equal to 0. So lambda is equal to 1 and lambda is equal to 0.5 are the roots of this equation. So if you want to write exactly the solution of that equation, then we will take that form y h of n will be equal to c1, that is 1 power n, and c2 to be 0.5 the whole power n. So this is called the homogeneous equation of the solution of the homogeneous equation. And to find the equation of the exact natural response of the system, we are supposed to find the values of these arbitrary constants c1 and c2. So we will try to utilize the given initial conditions. The initial conditions provided are y of minus 1 is equal to 1 and y of minus 2 equal to 0. So these are the initial conditions provided. I will consider the previous equation which I have got, like yh of n is equal to c1 1 power n plus c2 0.5 the whole power 0.5 the whole power n. When I replace this with uh, 0 and 1, actually, if I substitute n is equal to 0, I will get uh, y of 0 is equal to c1 plus c2, and y of 1, if I substitute n is equal to 1, y of 1 is equal to c1 plus 0.5 c2. So I will try to substitute these values in my previous equation number 1. So I will get it like y of 0 minus 1.5, because I can replace n is equal to 0 in my equation number 1. So I will get y of 0. So I can write it here, substituting in equation 1, y of 0 uh, and also n is equal to 0 in equation 1. So y of 0, equation 1 can be written as y of 0 is equal to 1.5 y of minus 1 plus 0.5 y of minus 2 is equal to 0. Since I have the equations for y of 0, I can replace that. We know that y of minus 1 and y of minus 2 are provided in the problem. So y of minus 2, this part becomes 0, and equation is y of 0 minus 1.5. Instead of y of minus 1, I can replace 1, which is equal to 0. So I will get what is y of 0. Y of 0 is equal to 1.5. Similarly, I can find what is by substituting n is equal to 1 in my equation 1. I will get y of 1 minus 1.5 y of 0 plus 0.5 y of minus 1 is equal to 0. So if I substitute y of 0 and y of minus 1 values, which I already know, I will get y of 1 is equal to 1.75. Okay. So I will consider the two equations which I have already found, like using the arbitrary constants. C1 plus C2 is equal to y of 0. So I will put 1.5, and C1 plus 0.5 C2 is equal to 1.75, which is y of 1. By solving these two equations, I will get C1 is equal to minus 0.5 and C2 is equal to 2. So using these two arbitrary constant values, I can write my homogeneous equation, which I have defined it like C1 1 power n minus plus C2 0.5 the whole power n. Replacing the C1 value and C2 value, I will get it like C1 is minus 0.5. Sorry, C1 is actually C1 is C2 is zero point 0.5 and C1 is 2 actually. Okay, I made a mistake. C1 is 2 and C2 is zero point 0.5. So C1 is 2 power 2 into 1 power n minus 0.5 the zero point 0.5 the whole power n. So this is my homogeneous equation. Solution for the natural response of the natural response of that equation which is intimated in the problem is 2 into 1 power n minus zero point 0.5 into 0.5 the whole power n.